Let's talk about functions for a minute. Some of you may be familiar with functions from your high school math classes, but a function is just a rule that assigns one output to each input. That's very important, that a function cannot have more than one output per input. So in order to call something a function, we need to have exactly one output for each input. So we can represent a function in multiple ways. So I have some of them on the screen here for you. So we can represent a function as a table. And here I have a function that represents the height of a plant based on the number of days since planting. So here on the what we would call the X value, we are showing the days, the number of days since this plant has been planted. So 0, 1, 2, 3, etc. And then on the Y side, we have represented the height of the plant. Now, some of you may be saying, this isn't a function. There are lots of zeros here in the Y column. But pay attention, please, to this differentiation. Remember, in our definition, we said that every input can have only one output. And you will notice that each day in our table has just one output for that day. So this is indeed a function. It can have the same output, but it can only have one output for every input in order to be a function. So this is a table representation. Over here, under number 2, I have the same data represented as ordered pairs. And our ordered pairs are always in the order the X value, comma, the Y value, and in parentheses. You can see that here we have 0, 0, and it's the same 0, 0 represented on the table. So the first 0, or the first value in each of these ordered pairs, represents the input, the number of days since planting, and then all of the values in the Y column, or in the Y, representing the Y in the ordered pair, is the height of the plant in centimeters. So then another representation for a function is a graph. And all we have done here is taken these ordered pairs and put it on a coordinate plane. Notice that the X value is on the horizontal axis, the Y value is on the vertical axis, and we put a point at each place represented by those ordered pairs. And then in this case, we've connected the line because we've got a continuous function from one day to the next. Okay, so we can see the change. Sometimes graphs are good for us to see patterns and changes in data. So that's a really good way for us to represent our function. And then finally, we can have an equation. And there are lots of different equations. For this function, it's not so easy to see the equation, right? But we can have different equations for functions, and some that you may be familiar with are linear functions, quadratic functions, exponential functions. So these are just examples. So we can take data that we have represented in a table as ordered pairs or in a graph, and we can write an equation. And for example, a linear function would be y equals mx plus b. We'll get into that a little bit in the next section. So all that to say that functions can be represented in different ways, and these are some of the ways to represent a function.